Hello, my name is Amy Tran, and this is our first Physics 2211 lab, constant velocity. The purpose of this lab is to verify if the constant velocity of an object can be accurately modeled by Newton's second law, or the momentum principle. Newton's second law is given by F equals ma, where the force and acceleration are vector quantities. For this lab, we know that if an object is moving at a constant velocity, there is no acceleration acting on it, meaning there is no force acting on it, given that by the relationship between acceleration and force in Newton's second law. Thus, the net force equals 0 newtons. Also, we know that the position update formula is given by displacement equals velocity times time. Since we have a constant velocity, we expect a linear relationship between displacement and time. We plan to model this interaction using Newton's second law and Python, assigning the system as the object in motion and the surroundings to everything else. The initial position is x equals 0 meters, or minus 1.04 times 10 to the minus 3 meters given in tracker. And the initial velocity, calculated by the change in position divided by the change in time from the first frame to the second, is 0.4189 meters per second. We assume that the object will continue to move at a constant velocity throughout the tracking period because the net forces on the object equals 0. We also manually approximated the location of the object in each frame by selecting what we determined was the center of mass. Possible sources of error include human error from eyeballing the center of mass in each frame, the presence of other forces acting on the object, and human error from cropping the video too close to the initial push of the object. At this point, we will look at tracker, where we modeled the position of our moving object relative to time. Our recorded values show us that our data is nearly linear and was not greatly affected by human errors. Now let's look at our glow script code. Our initial mass is 0.45 kilograms, which we found from the internet. We allowed our initial position to be at the origin and calculated the average velocity by dividing the distance the object traveled over an allotted time frame, 1 second. In our while loop, we applied Newton's second law to update both the object's velocity and position. Our results are exactly as we expected, where displacement and time are linearly related by a positive slope and velocity stays constant at 0.418 meters per second. Additionally, a plot of our predicted results versus our actual results is relatively collinear, meaning that the possible sources of error we suggested previously did not greatly affect our data. If we were to hypothetically flip the positive and negative directions, our graphs would be negatively sloped instead of positively sloped. Our results for position would also be negative instead of positive. Additionally, we cannot determine each individual force on the object. There are too many forces on the object that could be getting canceled out, such as friction or gravity, or they could be too trivial to impact our data in any real way. In this lab, we fairly and closely modeled the motion of an object using Newton's second law. When an object moves at a constant velocity, there is no acceleration and no net force, meaning that the displacement can be given by velocity times time in a linear relationship. Thank you.